Hello all, and thank you for listening to Mr. Laxton's video on these Algebra II 1.6 notes. Today we're looking at solving linear inequalities. Okay, so notice we're not solving equations anymore, equalities, we're solving inequalities. So there might be, if I look at here, these linear inequalities are like a less than, a greater than, a less than or equal to, or greater than or equal to. Okay, so that's really what it's going to be. It's kind of the same deal here, but we just have, instead of an equal to sign in the middle, we have a less than or a greater than or a less than equal to or whatever. Okay, and notice here that I kind of have some graphing here, which we're going to do first. A less than has an open circle, a greater than has an open circle, so those guys aren't actually equal to, so that circle isn't actually included into that solution. All right. So let's just look here. You can do adding, subtracting, multiplying, all these guys here. It's kind of the same deal. So you got to add 4 to both sides to get x all by itself for this first one. So we have x is less than or equal to 11. Okay, and the only real difference here is that now x doesn't equal 11. It's less than or equal to 11. Now just graphing this guy over here, I kind of just like to put 11 in the middle, 10 would be to the left, and 12 would be to the right on that number line. Okay, and then now you can kind of graph this in a bunch of different ways. I kind of like to put the dot, a closed dot right above it, and then my arrow, anything that's x has got to be less than or equal to 11, so anything that's less than or equal to is to the left there. Okay, kind of the arrow does point in the same direction here, so that's kind of a good hint for you, but your x has to be on the left side for the arrow to point in the same direction as that arrow. Okay, we'll talk about that a little bit too. All right, subtraction. Again, you can subtract things to both sides. Subtract, subtract. So now I get x is greater than 4. All right. So now again here I have 4, I have 5, I have 3 on the left. It is an open dot above 4 because it is just greater than, and all the numbers that are greater than 4 are to the right, like 5, 6, 7, 8, 9. All those guys are greater than 4. All right, next one, multiplication. We can multiply things to both sides again. I'm going to multiply by the reciprocal, 3 over 2, multiply by the reciprocal, 3 over 2. So this 3 cancels out here, the 2's cancel out. I get x is greater than, and here if I look, 4 times 3 is 12 divided by 2. So this is x is greater than 6. All right, so again, 6 in the middle, 7, 5 in there. Put an open dot above 6 and an arrow pointing to the right. All right, awesome. So now as I keep on going here, we have some special cases when we divide or multiply by a negative number. So if, and this is a key thing, so make sure you star this, if you multiply or divide by a negative number, you have to switch the sign. So if it's greater than, it switches to less than. If it's greater than or equal to, it switches to less than or equal to, things like that. Okay, here, dividing by negative. I divide by negative 4 to both sides. Divide by negative 4. So now I get x, and 16 divided by negative 4 is negative 4. But this switches, so this turns into a less than or equal to negative 4. So whenever you're dividing by a negative, you have to switch that sign. Okay, so now here I go negative 4. Be careful here, my negatives, that a number that's just to the right of negative 4 is negative 3, and this is negative 5. All right, a closed dot above negative 4, and then now my thing, or my arrow, points to the left because it's less than or equal to. Okay, same thing with multiplying. When you multiply by a negative, so if I multiply by negative 3 here to get that division out of there, I get x is greater than or equal to negative 27. All right, so here's negative 27, here's negative 26, here's negative 28. Be careful here that numbers that are greater than negative 27 are actually like negative 26, negative 25, because that's 0 all the way over there, which is greater than that negative number. All right, so there we go. That's how it works. If you multiply or divide by a negative number, make sure you switch the sign. All right, so I got to scroll down here to see what we got. Compound inequality. Okay, a compound inequality has 2 inequalities joined by an and or an or. Okay, The way that I remember this one, so now if I just look at a couple of these examples actually quick before we talk into that, x is less than or equal to 6 and x is greater than 2. So if I notice here, 6 is over here, 2 is over here. So x is greater than 2, that is a open dot at 2. And then x is less than or equal to 6 is a closed dot there, and my arrow would point over here. Okay, so notice how those guys come into each other. That's going to be huge. My OR is x is greater than, or excuse me, less than 8. So here is 8, and it's not a closed dot. It is an open dot. So here's 8. Here is 13. Any numbers that are less than 8 are this way. Any numbers that are greater than 13 are that way. All right, so OR... they go away from each other. So here's how I remember them. And is sandwiches. They come into each other. So they sandwich into each other and make a sandwich. The oars look like oars on a boat. So I'm not going to attempt to try to draw oars on a boat. But if I look at this, here we go. They go away from each other. They're oars on a boat. Awesome. So that's how I kind of like to remember them. And is sandwiches. They come into each other. They make a sandwich. Okay. So graphing these guys. Okay. Here for the first one, and compound inequalities. Notice here they have 2. That's kind of got this in the middle. There's no actual and in it. It's just got 2 inequalities in one problem. Okay, and the nice thing about this is that you can just solve this kind of the way it is, but trying to erase this that I just wrote on there, but it won't let me. The way that I'm going to solve this, I got to get x all by itself in the middle. So now I have to add 8, but you ask yourself, ooh, where do I add 8 to? You have to add 8 to this right side and the left side. So now I have 9 is less than or equal to 3x, which is less than or equal to 18. All right, so here if I divide by 3, and divide by 3, I'm going to get 3 is less than or equal to x, which is less than or equal to 6. Okay, so again, if I have 3 and if I have 6, it's going to be a closed dot above both of them, right? Because it's equal to. And this is so this is a sandwich. They're going to sandwich in between each other. So that's where my graph looks like there. Any numbers that are between 3 and 6 make this up here true. All right, good. Next one. Again, I got to add 6 to all 3 parts. Add 6. So now I have 3 is less than or equal to negative 2x, which is less than or equal to 12. Divide by negative 2. Divide by negative 2. Divide by negative 2. So notice, hey, what happens when we divide by that negative? It still happens here. You still have to switch that sign. So I have 3 divided by negative 2. That doesn't simplify. That's okay. Is greater than or equal to, notice how I switch that, x, which is greater than or equal to negative 6. All right, so here, make sure you know, hey, negative 6 is less than negative 3/2, so that's over here. They're both closed, and is in an and, so we both come into each other there. Okay, ands don't have any letters, don't have any words in them. They look like this, 2 and 1, pretty much. All right, that's an and. Now, ors are actually a lot easier because, hey, it just tells you in an or compound inequality, it says or in it. All right, so now I'm just going to solve both of these separately, straight down as 2 separate problems, and then graph both of them. All right, so this isn't too bad. I minus 4 to both parts here. I have 2x is less than 4. All right, I divide by 2. So now I have x is less than 2 is one of my parts. Okay, so now if I go through the next one, I'm going to have or, my second answer over here. I'm going to add 5. So I have 3x is greater than 18. Divide by 3. Divide by 3. I get x is greater than 6. Okay, so I have x is less than 2 or x is greater than 6. So I have a couple guys here. I have 2 and I have 6. I have open dots above both of them. And then this one you really don't even have to know, but they should look like oars on a boat, right? But now if you actually just graph these guys, x is less than 2, that's anything that's this way. X is greater than 6 is anything that's this way. So that is my final graph. All right, so again, they're linear inequalities, a lot very much similar to linear equations, except for kind of that different little graphing part. Don't forget, when you divide by a negative, you have to make sure to flip the sign. All right, so thanks again for listening to another one of Mr. Laxton's videos. I hope you enjoyed it. I hope you learned a little something, and we will talk to you a little bit later.